This lesson, section 9.2, is about estimating a population mean. If you remember, the symbol for mean, for population, is the Greek letter mu. The sample mean is x with a bar, so we call that x bar. So the point estimate for the mean, mu, is x bar. So we have what's called the student's t-distribution. And this deals with samples. If the distribution of the population is approximately normal, then we can use a formula for the t-distribution for all sample sizes of n. Notice we're talking about sample sizes. So t-distribution applies to your sample sizes. So we have some properties of the t-distribution. The shape of the distribution is different for different sample sizes. The distribution has a mean of 0 and is symmetric about 0, similar to the normal curve. The distribution has standard deviation greater than 1, so that means that we have more variation. And as the n gets larger, the t-distribution gets closer to the standard normal distribution. So we have a couple of requirements for the t-distribution, and that is that the population standard deviation sigma is not known, and either it's normally distributed or its sample size is large. And we're saying by large, we're defining it to be the sample size to be greater than 30. So if you look at this picture here, the inside graph, the orange, shows that t is equal to 5. So you can see that it has the lowest height. Then the pink has a sample size of 15, showing that for the t-distribution, the height's a little bit taller, and the normal curve. So you can see as we increase the sample size, the shape of the graph approaches the normal curve. So we say it's approximately normal. So we have that underlined here, that it is either population is normally distributed or the sample size is large, and the sample size is no more than 5% of the population. So we have some new keystrokes here, stat, test, and we're going to go to t-interval, which is number 8, where x bar is the sample mean, s is the sample standard deviation, and n is the number of trials. So if you notice, your point estimate for mu is x bar. That's our symbol. Okay, so let's see if we can keep the calculator keystrokes up here for us. All right, a study was conducted to estimate hospital costs for accident victims who wore seatbelts. 20 randomly selected cases. So that 20 is your sample size. Have a distribution that appears to be bell-shaped with a mean of 9,004 and a standard deviation of 5,629. Calculate the point estimate for the mean hospital cost for all accident victims wearing seatbelts. So that's x bar. So x bar is equal to 9,004 because the sample mean is equal to the population mean. Construct a 99% confidence level estimate of the mean hospital cost for all accident victims wearing seatbelts. So what do we need to know? Your confidence level is 99%, which is 0.99. X is equal to 20. The mean is equal to 9,004. And since it's a sample, I should be using x bar. And the standard deviation, again, being a sample, is S equals 5,629. So picking up your calculator, if you do second stat, or just stat, arrow to test, arrow down to number 8, it says T interval, and we will put in stats. Those are called stats. Okay. So we're going to say choose stats on the calculator. Okay, so you hit enter. And the first thing it says is x bar, 9,004. Then the sample standard deviation, 5,629. N is 20. Confidence level is 99%, 0.99. Calculate. And we get, for our interval, 5,403, 12,605. So we can say, I am 99% confident that the mean hospital costs for all accident victims wearing seatbelts is between $5,403 and $12,605. Okay, so let's look at another one that uses data. Not data yet. Last one is data. This is stats again. In a study of the length of time that it takes a student to earn a bachelor's degree, 80 students, here's your N, are randomly selected, and they are found to have a mean average of 4.8 years and a standard deviation of 2.2 years. Construct a 95% confidence interval estimate of the mean amount of time that it takes all students to earn a bachelor's degree. Write a sentence to interpret this result. So again, N is 80. X bar is your mean, 4.8. S is the sample standard deviation, 2.2. And your confidence level is 0.95. All right. So using the calculator, we will get 4,000. Oh, sorry. We have a decimal now. So 4.3104, 5.2896. That's our confidence interval. Okay, so what does this mean? I am 95% confident that the mean amount of time it takes all students to earn a bachelor's degree is between 4.3104 years and 5.2896 years. Okay, what is the point estimate and the margin of error? So p hat is your point, not p hat, we are in mean. Mean, it's x bar, proportion is p hat. So x bar is equal to, now this can come off with a calculator. Okay, or we can take an average. So x bar is equal to 4.8. Okay, and I worked this earlier. Let me double check this here. So again, stat test number 8, T interval. You just have to know, are you doing an interval or are you doing a test? And you will see the words interval. Point estimate, margin of error, all those have to do with intervals. So a lot of this is reading and picking out your data. So we knew that either from the calculator. Also, if you remember, the point estimate is 4.8. So it was actually given up here. That is your point estimate. Or it comes off the calculator. Or we can average it. So your error is equal to 4.8 minus 4.3104. It's easier to subtract the point estimate minus the right-hand value. And then we can take that answer and add it to the point estimate, and we'll get the left-hand value. And we get the error is 0.4896. And we've answered the questions. Now let's look at data. Here's data where you have a bunch of numbers. All right. The management of Disney World wants to estimate the mean waiting time at the Dumbo ride. They randomly select 14 riders. There's our n value. So let's note n is 14. Measure the amount of time in minutes that the rider spent waiting in line. The results are below. Assume the population is normally distributed. 90% confidence interval. So your confidence level is 90% or 0.90. But the true mean waiting time at the Dumbo ride. Write a sentence to interpret this. So if you notice, we don't have the mean or standard deviation. So number one, you have to put your data in L1. Okay, so if you recall that stat, then we do edit and put in data. So we're going to type our numbers in L1. So stat, hit enter for data. Now I have some in L3 and L2. I was working ahead, so I can clear those out. And we will put those numbers in. 30, 29, 34, 41, 37, 16, 18, 30, 24, 25, 29, 16, 19, and 30. And so I have 14 in there. And it said they selected 14 riders, so I'm good. So now you can go to Stat and Tests, arrow down to number 8 again. But this time we're going to choose data. Because we have data in there, we're going to let the calculator find our answer for me. So you're going to do second L1. Your frequency is 1. Okay, I have 0.95. I need to change that to 0.90. If I calculate, I get that X bar is 27. Again, this is from the calculator. Your standard deviation is 7.75. The interval is 23.334. 334. And 30.661. So I am 90% confident that the true mean waiting time at the Dumbo ride is between 23.334 and 30.661 minutes. Okay, so that is it for section 9.2. Have a great day.